Introduction. In our day-to-day life, we are using cubes often. For example, cube is a solid figure. We can find the volume of cube using a mathematical formula. It is commonly used in our day-to-day life. For example, assume that you have a cube box which contains some amount of oil in it. How much oil does the box contain? You can find the amount of oil using volume of cube. Objectives. At the end of this lesson, you'll be able to identify the cubes, identify the prime numbers to apply the prime factorization method, list the properties of the cube, identify the cube root, differentiate between cube and cube root, calculate cube root of a perfect cube without using prime factorization. Perfect cubes. The cube of a number is the number raised to the power 3. Volume of cube is equal to S into S into S, which is equal to S cube. When a number is multiplied by itself 3 times, we get the cube of the number. The cube of 2 is equal to 2 cube, which is equal to 2 into 2 into 2, which equals 8. The cube of 5 is equal to 5 cube, which is equal to 5 into 5 into 5, which is equal to 125. 8 and 27 are natural numbers which are cubes of natural numbers 2 and 3 respectively. Such numbers are called cubic numbers. Example. What is the least number that 500 must be multiplied with to make it a perfect cube? Solution. We have seen that 500 is equal to 2 into 2 into 5 into 5 into 5. 2 into 2 into 5 into 5 into 5 is equal to 2 into 2 into 2 into 5 into 5 into 5, which is equal to 2 cube into 5 cube. Hence, to make the factors into a product of triples of equal factors, 500 should be multiplied by 2. Example. What is the smallest number that 686 must be divided by to make it a perfect cube? Solution. Factorizing 686, we get 686 is equal to 2 into 7 into 7 into 7. The factor 7 is a triple, but 2 is alone. Therefore, if we divide by 2, the number obtained will be a perfect cube. 686 must be divided by 2 to make it a perfect cube. Properties of cubes of numbers. Cubes of even and odd numbers. If an even number is multiplied by itself 3 times, the result is an even number. Examples. 2 into 2 into 2 is equal to 8. 6 into 6 into 6 is equal to 216. 12 into 12 into 12 is equal to 1728. Also, when an odd number is multiplied by itself 3 times, the result is an odd number. Examples. 3 into 3 into 3 is equal to 27. 7 into 7 into 7 is equal to 343. 11 into 11 into 11 is equal to 1331. The cube of an even natural number is even. The cube of an odd natural number is odd. Cube of a negative integer. Look at the products given below. -1 cube is equal to -1 into -1 into -1, which equals -1. -5 cube is equal to -5 into -5 into -5 is equal to -125. Minus 10 cube is equal to minus 10 into minus 10 into minus 10 is equal to minus 1000. We conclude that the cube of a negative integer is a negative. The cube of a rational number a upon b is given by a upon b cube is equal to a cube upon b cube. Cube roots. If the cube of 2 is 8, then 2 is said to be the cube root of 8. We denote cube root by the symbol cube root. Thus, cube root 8 is equal to 2, cube root 27 is equal to 3, cube root 64 is equal to 4, cube root 1000 is equal to 10. Cube root. The cube root of a given number is that number whose cube is equal to the given number. Cube root of a perfect cube by prime factorization. Example, find the cube root of 1728. Solution. Carry out the prime factorization of the given number. 1728 is equal to 2 into 2 into 2 into 2 into 2 into 2 into 3 into 3 into 3. Make triples of equal factors. 2 into 2 into 2 into 2 into 2 into 2 into 3 into 3 into 3. Take one prime factor from each triple and find their product. 2 into 2 into 3 is equal to 12. 12 is the required cube root, that is, 3 cube root 1728 is equal to 12. Cube root of a negative number. We have seen that the cube of a negative integer is negative. For example, minus 5 cube is equal to minus 5 into minus 5 into minus 5, which equals minus 125. It follows that cube root minus 125 is equal to minus 5. That is, cube root minus 125 is equal to minus cube root 125, that is, minus 5. In general, if x is a positive integer, cube root minus x is equal to minus cube root x. Thus, to find the cube root of a negative integer, find the cube root of its absolute value and put a negative sign before it. For example, cube root minus 64 is equal to minus cube root 64, which equals minus 4. Cube root of product of integers. Example, find cube root 64 into 125. Solution. 64 is equal to 2 into 2 into 2 into 2 into 2 into 2. 125 is equal to 5 into 5 into 5. Cube root 64 into 125 is equal to cube root 2 into 2 into 2 into 2 into 2 into 2 into 5 into 5 into 5 is equal to 2 into 2 into 5, which equals 20. Also notice that cube root 64 into cube root 125 is equal to 4 into 5, which equals 20. Therefore, cube root 64 into 125 is equal to cube root 64 into cube root 125. In general, cube root AB is equal to cube root A into cube root B. Cube root of a rational number. We have seen earlier that A upon B whole cube is equal to A cube upon B cube. It follows from this that cube A upon B is equal to cube A upon cube B. Example: find the cube root of 729 upon 1331. Solution: cube root 729 upon 1331 is equal to cube root 729 upon cube root 1331 is equal to cube root 3 into 3 into 3 into 3 into 3 into 3 upon cube root 11 into 11 into 11 is equal to 3 into 3 upon 11, which equals 9 upon 11. Summary. Let us summarize what we have learned. The cube of a number is the number raised to the power 3. A cubic number of perfect cube is a natural number which is the cube of some natural number. A perfect cube can be expressed as a product of triples of equal factors. The cube of an even natural number is even, and that of an odd natural number is odd. The cube of a negative integer is negative. The cube of a rational number, a upon b, is a upon b whole cube, which is equal to a cube upon b cube. The cube root of a given number is that number whose cube is equal to the given number. The cube root of negative number is negative. Cube root ab is equal to cube root a into cube root b. The cube root of a rational number a upon b is given by cube root a upon b is equal to cube root a upon cube root b.